you're going to follow very similar steps to adding decimals. Step 1, you need to line up your decimals. Just like we saw with that one example, if you don't line them up, you're going to come up with a completely wrong number. Once you line up your decimals, we're going to the second step we're going to do is bring down the decimal or drop down the decimal and forget about it so that we can just subtract like normal. The third step is we're going to use our zeros to hold place. Very important subtraction so that you won't have the headaches. In step 4, we're going to subtract like normal. Let's do some examples now. If it took someone 7 8/10 of a second to run from one point to the next, and it took somebody else only 4.9 seconds, which is 4 9/10, we want to know how much faster that second person was than the first, because when you're running, the littler numbers are faster, right? So we're going to subtract to see the difference. So I lined up my decimals, and then my next thing was to drop down the decimal and forget about it. So I'm now just thinking about 78 minus 49. Okay, this is what I'm thinking. There's no zeros I need to put down because all my places have a match, so I'm okay on with my number of digits. There's 2 digits here, so 2 digits there. Now I may have to regroup if necessary, so let's go back to our notes, subtract like normal, and for our 5th step, regroup if necessary. Alright, if we have 8/10, I cannot get rid of 9/10, so I'm going to have to regroup. So I'm going to borrow from the ones place, and now I only have 6 ones. I'm going to give that one that I'm giving, I'm cutting it up into 10 pieces and giving it, so now there's going to be 18 pieces. 18/10 minus 9/10 would be 9/10. 6 wholes minus 4 wholes would be 2. So that person was 2 9/10 of a second faster than the first person. When you are doing any kind of subtraction, because addition and subtraction are called inverse operations, that means the opposite can be done to check, we're going to use addition to check our work, because if we don't end up with the same numbers when we do the opposite operation, then we've done something wrong. So we will take our difference, which is 2 9/10, and we're going to add it to the 4 9/10, which we were trying to get rid of a minute ago with our subtraction, and we're going to drop down our decimal like normal, and we should get this beginning amount when we're done. So 9 9/10 is 18/10. You can't have 18/10. You have to regroup it to one whole. Here you have 7 wholes. So we have 7 8/10, which does in fact match what we started with. So subtraction and addition can be used to check yourself, check your work. And I want you to try doing that on everything that you do with decimals, because decimals are kind of tricky. So it's better to be safe than sorry and check your work. Alright, I'm going to have you try just a problem. I'm going to go into a word problem. Three 6/10 minus 1 5/10. Go ahead and pause me and try. Okay, so you should have dropped down your decimal. Forget about it. 6/10 minus 5/10 would be 1/10. 3 wholes minus 1 whole would be 2 wholes, so 2 1/10 would be your answer. To check my work, I'm going to add these two together. So 1 5/10, 2 1/10. I get 6/10. 2 plus 1 is 3 wholes, and look at that, those two match, so I am good to go. Alright, in these next two examples, we're going to look at why it's very important to put 0 in as a placeholder. If you were to try to do the subtraction problem right here, and you try to just stick that 3 down, you will get it incorrect. So you've got to put your 0 in for the placeholder, and then you can subtract like normal.
Instead of 3 and 8/10, we know an equivalent decimal is 3 and 80/100. So we will do 3 and 80/100, and we will take away 2 and 43/100.
So I'm going to put my decimal down and forget about it. Over here, I have 0 minus 3, which I have 0 hundredths minus 3 hundredths. I can't do that, so I'm going to go regroup like I do in regular subtraction. And then I'm going to do 10 hundredths minus 3 hundredths, which is 7 hundredths. Then I have my 7 tenths minus my 4 tenths, which I can do in the traditional algorithm, so I get 3 tenths. And then 3 wholes minus 2 wholes is 1 whole. So my final answer is 3 and 37 hundredths. You would not have gotten the right answer if you didn't put that 0 down to hold the place.
The next problem we are going to look at with money. We have $5. If I have $5 and I take away or I spend $2.97, how much will I have left over? You'll see this problem is written horizontally.
So before you work the problem, you'll have to decide how to set it up. So you can set it up in the traditional manner, vertically, with your $5, and we can write $5 with our 5 in the ones place, and then we can use our decimals for our dimes and pennies. So we don't have any cents, so we have our decimal point and 2 zeros. Then we can write $2.97 lining up that place value, and then we can subtract.
Now, if you would not have added those zeros, you would not be getting the right answer.
For this subtraction problem, I'm going to do where I shifted on the number line by 1 each, so that I don't have to worry about all that regrouping. So I actually have $4.99 minus $2.96, and then I can subtract like normal, put my decimal down. 9 minus 6 is 3 hundredths. 9 tenths minus 9 tenths is 0 tenths. $4 minus $2 is $2. So my final answer is $2.03. You can go ahead and do this traditionally, and you will get the exact same answer that I did.